Hello and welcome back. This is chapter 4 on Earth, Moon, and Sky. Here is the Hubble Space Telescope back in 1993 being worked on inside the cargo bay of the Space Shuttle Atlantis. The telescope has been in space since 1990. Here is an example of latitude and longitude in our nation's capital, and we can see that lines of longitude begin in England and go west. Lines of latitude begin at the equator and go north to the pole. The Royal Observatory in Greenwich, England, is where the international line of longitude begins, the 0 point. In this type of pendulum, the Earth turns underneath the Foucault pendulum and can knock down these little balls every quarter of an hour as we rotate beneath it. We can see the seasons because of the tilt of Earth's axis. This tilt is 23.5 degrees. The sun's rays are stronger here in summer because of the more direct light. In the winter, the sun is at a low angle, and that produces shallow radiation. And so we can see that here on our globe. In the summertime, the sun is high above us in the northern hemisphere, and in the wintertime it is low in the sky. We can see what the Earth looks like on the first day of summer, with the Tropic of Cancer up here and down here, facing the sun's direct light. On the first day of winter, the Tropic of Capricorn is in the direct sunlight, and in the northern hemisphere, it is winter. Now there is a little bit of difference between a solar day and a sidereal day. That word is sidereal, and it's important. A sidereal day is the amount of time for the Earth to go around the sun once, plus an extra day to make up for the fact that we are in orbit around each other. So a sidereal day is a little bit longer. The date changes at the international date line out here in the open waters. Stonehenge, a very ancient monument that was used to track the motions of the sun and moon. If you ever go to England, be sure to go to Stonehenge. This is a very old observatory in Mexico. It dates around the year 1000. Your lab for Module 2 will look at phases of the moon. And so here we see a classic diagram of the different phases. There are 8 of them that the moon goes through in a month. And so you will want to refer to this diagram as you do the moon phases lab. Now the pull of the moon has an effect on tides and the water on the Earth. So as we go around the moon in our orbit with the Earth, we can have different tidal changes, a little bit of an effect with the sun as well. So here we have high and low tides, a side-by-side comparison in the Bay of Fundy in Canada. Quite dramatic. We can also have different kinds of tides depending on where the Earth, Sun, and Moon are located. George Darwin is best known for studying the Earth's spin in relation to angular momentum. A solar eclipse is when the Moon completely blocks out the Sun and casts a shadow onto the Earth. We will have a total solar eclipse again in 2024. We had one in 2017. In the geometry of a total solar eclipse, which I saw in 2017 in Missouri, this diagram not to scale, but a little bit of a shadow from the Moon hits the Earth, maybe 120 miles in diameter. And under that shadow, we see the total solar eclipse, like we see in this picture. In a lunar eclipse, the Moon goes through the shadow cast by the Earth out into space and turns a dark red. This was the 2017 total solar eclipse. Again, I saw it here in the middle of Missouri. Nowhere near most of you guys. And that's the end of chapter 4.